Question on the homework assignments. Yes. Yes. You're welcome. So the first thing we're looking at is complex conjugate. If a polynomial of real coefficients and a plus b I is an imaginary zero, then a plus minus bi is also. So for every a plus bi, its complex conjugate is a minus bi. So if we look at the first example here, 7 minus I, its complex conjugate would be 7 plus I. 7 plus I. Questions on this so far? Now the next thing I'm going to do is find their product. I'm just going to multiply them together. Yes. Now 7 times 7 is 49. 7 times I is plus 7i. Then we do the same thing with negative I. Negative I times 7 is negative 7i. And negative I times I is negative I squared. Well, 7i minus 7i is 0. 7 minus 7, 0. Minus. Well, I squared, we said yesterday, is negative 1. So at this point here, we have 49 minus negative 1, which is 50. Because our minus and negative is the same as plus, so we have 49 plus 1, which is 50. Now that's interesting because we started with two terms with I and ended up with a single number that does not have I. And that's the nice part about complex conjugates. When we multiply them together, the I term simplifies out. Good number. Mm-hmm. No. Miss Kendall's mom got a whole box of them.
Oh, really? Can you guys hug? Does it turn into like an actual Oreo? Mm-hmm. What's your wife?
Martin Luther. With the 95 Theses nailed to the chapel door.
Because I was wondering, she has a hamburger.
Yep. Number 2, what would its complex conjugate be? Yes. Now we do need to multiply them together to find out what their product would be. Well, we did this yesterday. Negative 5 minus 5i times negative 5 plus 5i. Because we can type these into the calculator and let the calculator do it for us. And incidentally, their product is 50. So here the complex conjugate is negative 5 plus 5i, and their product is 50. So looking at number 3, negative 2 plus 4i, the complex conjugate would be negative 2 minus 4i. Now to find the complex, or their product, we would take negative 2 plus 4i and multiply by negative 2 minus 4i. Negative 2 plus 4i times negative 2 minus 4i is 20. What will the complex conjugate of 3 plus 6i be? Or 3 minus 6i? Well, 3 plus 6i. Because we're just changing the sign in front of the I term. And their product would be? I believe it's 45. Second decimal. Questions on this here? 10 minus 2i would be? Now we need to find its product. I put the little swoosh on there just to kind of signify that we're talking about I as the imaginary term. Now, the other way, well, and I believe you got their product as 104, is they will write it with a hat. I think of it as a hat. That's the other way we can write I as the imaginary number. Let's do one more and then we'll move on. Because this would be negative 4 plus 8i. And if we multiply them together, we should get 80. Actually, I want to do 2 more. What would the complex conjugate of 8i be? And then if we multiply these together, we would get 64. What's the complex conjugate of 7? Because when we go from one to the other to get its complex conjugate, we change what? The sign in front of I, yes? So for the first one, 7, we could say it's plus 0i. Its complex conjugate would be 7 minus 0i. Well, 7 plus 0i was just 7. 7 minus 0i is still just. All right. We got into the last part of the notes. Write each quotient in standard form. We cannot have I in the bottom of a fraction. That's really what this is getting at. Well, maybe we can type them into the calculator. Alpha y equals enter will give us the fraction. We can go and type it in. 4 plus 3i. Over 1 minus 2i. Error data type. Somebody else try to type it in? I got same thing. Okay, so the calculator's being a little difficult. So I'm going to show you how to do this by hand. Then we'll come back to the calculators in a minute. Now, what the main issue is that we have I in the bottom of the fraction. We need to get rid of it. And we've seen a way to get rid of I by multiplying a complex number by its conjugate. Because the complex number and its conjugate, when multiplied together, we've seen it for all the ones today, it reduced to a single number. We didn't have I anymore. So what's the complex conjugate of 1 minus 2i? 1 plus 2i. which, yes, it will be 4 when we get there. So, to simplify this fraction, to write it in standard form, we're going to multiply the numerator and denominator by 1 plus 2i. But in essence, what is 1 plus 2i divided by 1 plus 2i? Anything divided by itself is 0. 1. So 1 plus 2i over 1 plus 2i is just a fancy way to write 1. So we're not really changing the fraction itself, because anytime we multiply by 1, it stays the same. We're just changing how it looks. Now in the denominator, we're going to do 1 times 1 and then 1 times 2i. Well, 1 times 1 is 1. 1 times 2i would be plus 2i. Negative 2i times 1 be negative 2i. And negative 2i times 2i is negative 4i squared. If we do the same thing with the numerator, 4 times 1 would be 4. 4 times 2i is plus 8i. 3i times 1 is plus 3i. And lastly, 3i times 2i is plus 6i squared. Now we can do some simplifying. Our 8i plus 3i in the numerator is 11i. Now I squared, we said it already today and yesterday, is negative 1. I squared is negative 1. In the denominator, we still have 1, but our 2i minus 2i is 0. Minus 4. And again, I squared is negative 1. Now we still have I in the numerator, but that is fine. But the denominator, we do not have I anymore. They all simplified out. Well, 6 times negative 1 would be negative 6 plus 11i. Negative 4 times negative 1 would be plus 4. Unfortunately, it is not 4. It's actually 5. 4 minus 6 is negative 2 plus 11i. So that is one of the answers. Technically, standard form, we'd have to split the fraction up. Negative 2 fifths plus 11 fifths I. I will take it in either version. Questions on any of this here? Now, it would have been nice if we could have typed this in, hit enter, and it gave us an answer, yes? Well, that is the answer we got, isn't it? Now, the difference is, one, this is a TI-84 plus CE. It's one after the ones we have. But there is a way to type it in. It just takes a few more steps. So if we look at this one here, fraction, the fraction bar is just another way to say division. So really what we're saying is that we have 1 minus 4i divided by 2 plus 3i. So let's try typing it into the calculator that way. 1 plus 4i divided by, second, there we go. So 2 plus 3i? Okay, 2 plus 3. I couldn't remember what it was. Go ahead and type that in. And hit enter and see what you get. You get this there, yes? We're not quite done. because we do need these as fractions, not decimal, so we'll hit math. And the first one is fractions, so enter to select it, which is saying take the previous answer, turn it into fraction, hit enter one more time, and we get I see why. Because the numerator is not 1 plus 4i, it's 1 minus 4i, math, enter, enter. Negative 10 thirteenths minus 11 thirteenths. What'd you type in?
That's a numeratic thing.
1 minus 4i divided by 2 plus 3i. And then you hit math, enter, enter. So we all get negative 10 thirteenths minus 11 thirteenths. Give this one a try. 2 plus 5i over 4i divided by 4i. So we say 2 plus 5i divided by 4i. We may or may not need the parentheses around 4i, but it's better to have them and not need them than need them and not have them. Math, enter, enter. Let's do one last one. 1 plus 4i over 2 minus 3i. Parentheses.
Oh.
Yep. So when, possibly. It is. It is an app for me. Download it.